Okay, hello everyone. Today we're going to be starting data structures part 3. Sorry, continuing on to data structures part 3. So we already learned about a few data structures and today we are going to be learning about more. So just a quick recap, a data structure is a primitive data type. It is composed of primitive data types. It can contain multiple of these primitive data types such as strings, booleans, numerics, etc. And then each of these data structures will have their own methods which they can perform, which will help us use these data structures and use the information that we are storing in them. So today we're going to be looking at lists. A list is an ordered collection of non-unique values that are of any type and are mutable, right? So let's see. So we did arrays last time, right? So the only difference between this, the list, and an array is that in an array, the values cannot be of any type. Um, in a list, however, they can be of any type, right? So, except for that, they are pretty much similar in the fact that the order in which you put the elements will be the order in which they are put into the list. And then you can also use indexes, and you can also use sectioning to get data from that list, and it will still be in the same order you put it in. Also, these values can be non-unique. They don't have to all be unique, so there can be multiple of the same values within the same list. The next thing is that they can be of any type. So this is where it is different from an array, right? Because an array can only have one type, be it a number or a boolean or a string. But a list can only have one type of a list can have any type of data. So for example, um, you see this over here, right? So this has multiple types of values. It has a string, it has numbers, it has boolean values. The last thing is that these are mutable, so you can alter these lists and you can change the values in it. Okay, so clear this and clear next page. Okay, so accessing individual elements. So indexing is exactly the same as we did in arrays. So if we have, sorry. So for example, if we want the first element, we use 0, second element 1, and so on and so forth. Similar to arrays, you can also use negative indexes to start from the back, and these start from -1 because 0 already stands for the first value. We can't use it at the back as well. So from the back, it starts from -1. From the front, it will start from 0. You can also use it to replace a value. So if you do, for example, if you want to change the 10th element, you will do my list 9, right, in square brackets, and then you can change that value to, let's say, 10, and then it will be changed as you can see here. So next we come to list slicing. So list slicing is very straightforward. We use it to grab a portion or a slice of the list, right? So there will be cases when we need just a particular portion of a list. So for that, we have some ways that we can do this, right? So the first is we take a particular index, we take that element and every element after that, right? So the way we write that is shown over here, right? So it will take the third element of the list, and the third element and everything after the third element will be put into a new list, and that will be returned to us. That is the answer down here, right? If you can see it better now, so right over here. And then you can also use negative indexes here. So if we use -3, it will go from the back, right? And it will take the third element from the last and every element after that. So from some index to another. So for example, we want from one index to another index. So in this, the first one is included, right? So for example, in here, we've written my list 3:5, right? So the 3 here will be included. So the element at index 3 will be included, right? And the element at index 5 will not be included, right? So you will have the third element, fourth element, but you won't have the fifth one. That's why we have only two values over here. Similarly, you can use negative indexes here as well. That is completely acceptable, right? Just make sure that the second index that you are using is smaller, sorry, is larger than the first one. Otherwise, you will just get an empty list, which can be useful in some cases. But as a general rule, you should try to make sure, right? So up to some index. So this, in this case, we will take all the elements before an index, right? So my list, and then we put a colon and then 5. This means that we take all the elements until 5. We don't take the value at the fifth place, right? So we have 0, 1, 2, 3, 4. We don't have 5. Okay, so moving on to the next page, we have list methods, right? So these list methods are mostly similar to the array methods. You can use most of them, right? You can use count. So count counts the number of elements with the pass value. So you take a list. This can be either a list like this, or you can have a variable which has a list in it, and you can do dot count, and then you put a bracket in, and then you count the number of twos that are in there, right? So this has 4 twos, that's why it returns us a 4. Next we have extend. So this extends the list by appending the values of the past list to the end. So what happens is it will take the first list, it will take the last list, and then it will just join them completely, right? So next we have reverse, which is pretty straightforward. It will take the list and reverse it. And then we have sort. So when we're trying to sort a list, we can do this two ways, right? It's either ascending or descending. So if you do reverse equals to false, then it is ascending order, right? You don't need to write reverse equals to false because this is the default value. However, if you do need a descending order, you do need to write reverse equals true. Lists and strings. So this is a side note of sorts, and it shows that you can use these indexing and slicing methods in strings as well, right? So most of the methods that you can use in a list can also be used in a string. So the idea behind this is that a string is essentially a list of characters, right? But however, some methods don't work. So before you use a method, make sure it is working, right? So always be running your code and make sure everything's working properly. For methods that don't work on a string, simply cast to a list, do the method, and then make it into a string again, right? Next, we have a tuple, an ordered collection of non-unique values that are of any type and are immutable. So the only way this differs from a list that we just did is that it's not mutable. So you can't change the values inside a tuple. Once you put something inside, it's in there, right? The elements within a tuple have a defined order. So the order in which you enter them is the order in which they will remain, correct? So also you can have any types in there. They don't need to be unique, but you cannot change them. So for example, if you try to do my tuple and then you use index 9 and you try to change it to a 10, you can't do that because it's immutable. Like lists, tuples can be indexed and sliced, right? So you can still access values. Using indexes is not illegal. Using indexes to change values is illegal, right? Just keep in mind, tuples are immutable. Yeah, this is exactly what I was talking about. So just keep this in mind. You cannot change values in a tuple. If you do need something that can be changed, you should not be using a tuple. You should be using a list, right? Because that is mutable. Uh, Tuples can be useful in cases where you have a set data and you know that data is not going to change. For example, you can have a list of the days of the week and you know for a fact that you wouldn't want to change it later on because the days of the week don't really change as such. Then we have tuple methods. You can use index, which basically does the same thing as a square bracket. And then we can use count, which we also saw in a list. It works exactly the same, and you can use it to count the number of any one particular element. Because tuples are immutable, many of the methods that lists and even sets have aren't possible on a tuple, right? So if you're trying to use a method on a tuple, just think about it and make sure it's not changing the tuple in any ways. Worst case scenario, if you do end up using something that does change the tuple, it will give you an error and you will have to change it. So just keep that in mind. So these are some additional resources that you can access to gain more information, and these might be helpful in your assignment as well. And with that, I'm going to switch over to giving you guys examples. We're going to start with a list and some small indexing examples, and see you on the other side. Okay, so all right, so we have some answers in chat for what will happen when we try to print li until -4. Okay, so let's try to resolve this, right? So I'm just gonna make a quick comment here. So this is 0, right? This is 1, this is 2, this is 3, 4. Oh wait, we have to start from the back, right? Because we're doing minus. So we have 1, 2, 3, and 4, right? So this is -4. So it will print everything until here, right? So, but not including this. So it should print all of these values. Did anyone get that answer? Uh, so it looks like nobody got to that answer. So if we try running this, we can see, yeah, it does still -4. So this is -1, right? 6 is -1. This is -2, 2.1. This is -3. And this is -4. And when we do until, that is when we put a colon and then a number, we don't include the number at that index and we take everything until that index. That's why we have all of these values and not 5 in there. Yes, so the reason it doesn't include 5 is that the second part of the slicing. Oh, okay. So yeah, so the slicing, the second part of the slicing, the second number, which is after the colon, that will always be not included. The value at that place will always be not included. And we will include everything until that value. So all of these will come and 5 is not included. Is it clearer now? Or does anyone still have a doubt as to why 5 didn't make it? All right. So let's try something else. Next, we're going to do this. What will this give us? I can write down the values with you. What will be the answer? Even if you guess wrong, that's fine. You should still guess. Okay, I see two answers. Anybody else? Okay. Okay, so we have a few answers in here. So I see a couple that are right. So we're going to examine this part again correctly, right? So let me just zoom in case it's not visible. Oh, okay, it's not letting me window. Okay, never mind. So this is 6, and then we have a colon, and then the square brackets end, right? So the number is before the colon. So what that means is we take the number at that index, we include that, and then everything after that, right? So the number at the 6th index is 0. So we take 0, and then we get 2.1 and 6 in there as well, right? So yeah, so it should be 0, 2.16. So let's run this. Yeah, you get 0, 2.16. So is everyone clear on why we got that instead of the answer you were thinking? Does everyone understand the difference between the number being before the colon and after the colon? Okay, yes, I can repeat. So if the number is before the colon, right? In the last case, the number was after the colon, right? Before this, we were doing print li -3, right? Okay. So this number was after the colon. That's why we took everything until that number. But when the number is before the colon, we take the number at that index and everything after that. Is that more clear? Okay. So let's try another one. Oh, we have a question. Okay. So let's try this. Okay. Who will tell me the answer for this one? This is a tough one. This is not, this is a kind of a screwball. You can take your time. I can write down the negative indexes here as well if you would like that. Okay, we have one answer in chat. Is there any other answers? Okay, same answer. Okay, let's try to see what's happening, right? Okay, we have another answer. Okay, so when we do slicing, we first see the first element, right? So this is -9. Oh, so the value at -9 is this number. So we take the first number, right?
the value at the first index, we take that number. So we take the 1, right? Then we take everything after that until this value, right? So we take 1 to 5, and then we don't include the sixth value. So we don't include the 0. So this will be our answer. So if we try to run this, right? So does everyone understand why we got this answer? So the left one is being included always, and the right one is being excluded always, right? So we don't take the sixth value, and then we always take the first value. Oh, sorry, yeah, we always take the first values. Okay, so I don't see any other doubts. If you still don't understand, I can explain it again. That's not a problem. Okay, so I don't see anything in chat, so I'm going to continue. If you do have any doubts, you can still type it in chat and I will continue to answer along the class, right? So we have that done. So what do we have up next? All right, so we have some methods, right? So we did count. So let's make a new list, right? I'll comment this out for now. Make a new list li. Okay, what's the answer for this one? Let's see who's paying attention. 4. We have a 4. Anybody else? All right, so let's try to run this. A lot of people think the answer is 3, right? So when we run this, we get 3. Yes, it's because we're counting the number of threes that are there. So 1, 2, and 3, right? So 3 is indeed the correct answer. So next, we're going to try and do. Is there any doubts here before I continue? Why count gave us 3? I think it should be pretty straightforward. But it's fine if you have a doubt. I can repeat myself. Okay, so I don't see anything. I'm going to keep going. And then let's do this. So what will this do? Okay, let me just make this shorter so you don't have to type all that much. Oh, any guesses? Okay, so it will add up 3, 2, 4, 5. Okay, let's see. So we got none. Interesting, right? Why did we get none? Okay, so if we try doing this again, right? Now it printed what we were expecting, right? So what I wanted to show you was that when you do a method on a list and then you try to print it, it will print what the method is returning and not the list itself. We will get more to how values are returned in methods and functions. But for now, you should know that you extend first, then you print, right? So this is how it should be. So if you run this, you don't get a none, right? All right. So then we have reverse. Oh, there's something in chat. Okay. So we have, okay, what will this do? Any guesses? We have a none. We have one, two, three, four. Okay, so to the person who's thinking none, so we were getting none because we were trying to print out the method itself. But when we print the list, that won't return none, right? So this will still give us a list because li is still a list unless you delete everything in there. But even then, it will give you an empty square bracket instead of saying none. So we have someone saying in chat that it has to include false or true. Okay, let's try running it, right? So it ran. So the function I think you are talking about is the one we were going to next, which is the sort. And then inside that, we have reverse equal true. So don't confuse the two functions. Those are two separate functions, right? So for the sort function, I'm going to use this list again. Let's comment this one out, right? The only reason I want to use that one is because it's unsorted. So both ways will give us a different answer, hopefully. Right, so, okay, what will this do? You don't have to write down the entire list. Just tell me whether this will be ascending or descending. We have an ascending. We have someone saying descending. Hmm, okay. So, yeah, we have a lot of people saying descending. So the correct answer is indeed descending. So it will go from biggest to smallest because when we don't put anything in here, right, the default value is actually ascending. So if whether or not you write reverse equals false makes no difference. But if you do need descending order, you need to write true. Does that make sense? Why it works even if you don't put anything in there? Because the default value of reverse is false. Right. So basically if you need ascending order, you can simply use dot sort and you're done. Right. You don't need to write anything inside. But if you need descending order, just do reverse equal true. That's it. I know I said something different in the slides. That's simply because you can write false here and it will still give you ascending order, right? But it's the default value, so you don't need to write it. You can simply omit it. Same answer, right? So moving on to the next part. Mm, okay, we have tuples. So we can make tuples the exact same way that we made lists, except that we use round brackets. Sorry, round brackets instead of the square ones, right? So you can do that. So slicing works exactly the same, right? Indexing also works exactly the same. Okay. Then what else did we have? Uh, okay, so index, we can index it, we can count it. Those are also exactly the same. But then I'm actually not sure if sort works. So let's try it out, right? No. So the reason this doesn't work is because to sort an element, you'll need to change their indexes. And as we know, we can't change a tuple. We can only view the values in it, right? So any method that has to do with viewing, you can use, but any method that will change the order or change the values inside it or remove any values, you can't use those. All right, so I don't really have much on tuples in terms of exercises. If there's something you would like me to do, feel free to put that in chat. Um, it's pretty much the same as a list, except that you use the round brackets, right? And that they're not changeable. Okay, so I'm going to wait for another 2 to 3 minutes for questions before we end class today. What are the practical functions of tuples and lists? So there could be some sensitive records, right? Such as grades of your students, which you don't want anyone to just come in and be able to change them, right? Once they have already passed the class, for example, it's an old record. So we'll put that in a tuple and we won't be able to change it, right? And a list could be used for any sorts of things. For example, if you simply have a grocery store, right, and they want to keep a track of their inventory, and inventory can come in or come out, so you will have to use a sort of three-dimensional list, which sorry, two-dimensional list, which I will get to probably later on in this semester. If I don't get to it, you can feel free to come up to me and ask me about it, and I would feel free to uh, give you some extra information about that as well. Does that answer your question about how we could use tuples and lists? Do we still have room to submit our assignment? Yes, so I'm extremely sorry about this delay, and you can take until 1 week after I send the email. So it should be next Wednesday, if I'm not wrong. Right, okay. So, any more questions? All right, I'm gonna stop recording at least.